Example 4 is 3x squared plus 10x plus 3 over 2x cubed plus 2x. All right, this one's going to be a little more challenging because the denominator is going to be a quadratic. And at the beginning, I showed you those rules, and I showed you that you have to think about linear or quadratic factors. So let's break this down. They have 2x in common. Take that out, leaves you with x squared plus 1. So that's the two denominators we're going to go with, 2x and x squared plus 1. So something over 2x, that's kind of the easy one. Now you got to be really careful. I'm going to start with the denominator so I can talk about what I'm doing here. We've got a quadratic, x squared plus 1. And I've tried to prove this in the past, and it really just gets lengthy, and I don't know if it's necessary. Just kind of accept that when you have x squared here, you have to account for every power of x kind of counting down that could happen. We can't have the same power on top and bottom. Otherwise, that's a situation where we need to do long division, and we'll get to that. So far you've had linear factors. Everything's been x to the first power, so one variable on top's fine. So what you got to do here is say bx plus c. It's not so much important what the letters are, but something times x plus something that's just a constant. All right. So that's the main thing here. Everything else is going to kind of play out like it usually does. This one's actually a little bit easier overall, but that's the thing you got to really be careful of. Okay. So multiply by that denominator, 2x cubed plus 2x on this side makes it go away. Multiply by that on the other side, 2x times x squared plus 1. I'm losing my place here. So 2x times 2x goes away. Tell you what, I'm getting ahead of myself. 3x squared plus 10x plus 3 here. All right, now it's back to here. 2x's will go away. So a will be multiplied by x squared and by 1. So ax squared plus a. All right, the bx squared gets multiplied by 2x, so 2bx squared. And the c gets multiplied by 2x. And I didn't explain why, just in case you're still kind of iffy on this part. When you multiply by that common denominator, which is, I broke it down to make it easier here, you have the same thing on top and bottom. They're canceling out, so this multiplies by 2x. Okay, so now we've got our 3x squared. We've got a regular ax squared. We've got 2bx squared. And that'll do it for the x squareds. We've got a 10x. So look for everything that has x's with it, and that's just going to be 2cx. And this is kind of easy. The constant's 3. There's only one constant left, and that's a. So that looks like we got them all. All right, well, that's kind of my key here. I'm going to start with that because knowing that's true makes things a lot easier. All right, so x squared, so we can get rid of that because we know they're all x squared. A is 3, so go ahead and put 3 there, plus 2b. So 3 minus 3 is 0. B is going to have to be 0. I don't know if we've had that happen yet so far, but if b is 0, that just means we put 0 here, and the term with x is going to be gone. That's simple as that. And then the last one here, if we get rid of the x's, 2c, c is going to be 5. So there we go. A is 3, b is 0, c is 5. And to wrap it up, let's put a 3 over top of 2x for a. B is 0. I'm not going to write that because 0 times x is nothing. But I do have a c that's 5. And that's over x squared plus 1. And that'll do it. That's your fraction broken down. Example 5 is a little different because we got x minus 1 cubed on the bottom. Now, one thing you could do is expand this out, which wouldn't be too bad. We've done the binomial expansion stuff now. You can do Pascal's triangle or something like that. And I promise that it'll check out to what I do here, but this is a shortcut. And if you want to use this, I really encourage that you do. So it's kind of weird, but it'll sort of make sense, I think, as we work it out. Right at the beginning, it might not make a lot of sense, but it's possible that I have, I don't know why I just put x minus, or x plus 1 should be x minus 1 right there. I'm just going to scratch that and move it down here. It's possible I have a term that's x minus 1, and it's also possible I have another term that's x minus 1 squared. And I'm probably going to need another one that is x minus 1 cubed at some point. That one's probably not surprising. The other two, you may not have thought of right off, but it should make sense that if I have multiples of x minus 1, or multiple powers, well, I could multiply x minus 1 squared by another x minus 1 and get x minus 1 cubed. So, I mean, you could get a common denominator from those pretty easily. So that is the way you want to approach it. It's kind of a weird idea. It's x minus 1's cubed, so you could have up to 3x minus 1. So you need to account for every scenario, 1, 2, or 3 of those. Another sticking point is this part right here. All right, I got a b on top. I've got x minus 1 squared on the bottom. Shouldn't I have bx plus c? Again, you can do that, and it will check out. And it turns out it's going to be a whole lot of extra work. This is just another one of those little shortcuts you can look out for. If the term is linear, but it's raised to a power, and like basically if it's in parentheses, it's linear. X minus 1 is a linear factor. If it's raised to a power, though, you can get by with this. Again, I could do a little proof. It's pretty messy, and I don't know if it's really necessary, but it checks out and works. So this is a little shortcut, a couple of shortcuts going on in this problem. We've done it in the past just to see. We've worked it out where it's like a, this is bx plus c, and then this one's cubed, so you have dx squared, ex, f. It gets really lengthy, but it works. It checks out. It's just way longer. So same idea, multiplying by the common denominator. So I'm going to keep doing this. It's probably getting redundant at this point, but I just want to make sure everybody's following that. And on this side, I'm just going to write it like that, because if I multiply a over x minus 1 times that, one of those goes away. So a times x minus 1 squared, and I'll work that out in a second. X minus 1 squared, x minus 1 cubed, one of the, or two of those cancels out. So b times x minus 1. And they all go away here, so it's just c. So let me get a scratch paper and let's work out x minus 1 squared. We've done that a lot. It shouldn't be too bad. X squared minus 2x plus 1. I think it's a good idea to go ahead and do that, just so you kind of have it right in front of you. I find I make a lot of mental mistakes if I try to do it all in my head. So ax squared minus 2ax, and then a times 1, so plus a. All right, then bx minus b plus c. Okay, so there's all of our pieces. Now, on the left, a lot of these are going to be 0, so that's kind of nice. We don't have an x squared, so 0 is going to equal ax squared. And that's it. That's only, so a is 0. That's done. That's kind of nice. All right, we got 2x. That's going to equal negative 2ax plus bx. And looks like that's it for the x's. So 2 is going to equal negative 2a plus b. We'll probably need to do a system for that. And we don't have a constant. So 0 is going to equal a plus, actually minus b, and then plus c. Okay, so that looks a little silly, but it'll work out. All right, we got them all. So that's our system. Now, remember, a is 0, so I can go ahead and put that in. I want to get that part right, too. So c and b are equal. If you think about how that works out, negative b plus c, we'll move b to this side. They're the same. All right. And I also know that a is 0, so 0 plus b, so b is 2. And c equals b, so c is also 2. So we're done. That wasn't too bad. All right, a is nothing, so there won't be a term over x minus 1. b is 2, and I've got b being over x minus 1 squared, so I'll need to put that in. c is 2 also. It's over x minus 1 cubed. And that's it. That's our breakdown. All right, last example, example 6. This is the first time that you've had a denominator or a numerator that's bigger than your denominator. So it's an improper fraction, basically. What we're going to do is long division, and then we're going to end up breaking down the remainder. So let me jump in and kind of let you see how that plays out. I went ahead and just did the work here, and I would recommend maybe you pause it right now if you're not sure about the long division. I just figured it wasn't really necessary for me to show all this, so I would just pause it, maybe take a look at it, make sure that makes sense. Just realized I forgot to write this part in. That should be a 15. So anyway, we end up with this whole number part, x squared plus 2x minus 3, so it's a quadratic. And we have a remainder. The remainders always go over top of, I botched that, I'm sorry. 3x plus 4 is our whole number part. And 7x plus 13 is the remainder that's going to go over top of x squared plus 2x minus 3. There we go. So hopefully you got through enough of that to not send me too many emails about it being wrong. All right, so I'm going to come down, and instead of being an improper fraction, let's think of it as being a proper fraction now, where it's 3x plus 4 plus the remainder, 7x plus 13 over x squared plus 2x minus 3. All right, so that 3x plus 4, that's going to carry through to the end. That's kind of done. No more work needed. Good news. But this part looks like the partial fractions have been dealing with, because that can be broken up into two more fractions that we could do some more work with. I don't think I've mentioned it yet. Just figured probably a good time to do it. You're going to use this stuff in calculus with what's called integrals, and you can probably sort of imagine that dealing with something like, well, like this thing, doing your calculus magic is going to be pretty lengthy. But if we can break it up into some smaller, simple pieces, it'll be a lot easier to do your calculus on. And that's where this comes in. I mean, you could do it with what you got here, but it's a mess. Breaking these down makes your calculus way easier, like an hour shorter probably. All right, so let's break down this part. We've got, let's get this scratch paper out. Probably do that in our head, but anyway. X plus 3 and x minus 1. Seems like I would check out. So I'm gonna, again, this is done. I'm going to just break down this part. The 7x plus 13 over x squared plus 2x minus 3 needs to be something over x plus 3 plus something else over x minus 1, since those are my two factors. All right, so multiply by our common denominator so we can get that out of the way. It's gone now. And on this side, I'll just write it kind of broken down again. So 7x plus 13. All right, well, if I multiply this term by the common denominator, x plus 3 goes away. So ax minus a. And this one, the x plus 1 will go away, so bx plus 3b. All right, and hopefully this will be pretty straightforward from here on out. 7x will be ax plus bx. And a 13 constant will equal negative a plus 3b. Okay, so drop the x. And I'm sensing some elimination here. We got a and negative a. Let's go that route. So 13 equals negative a plus 3b. All right, the a's can add to 0. So 20 equals 0 plus 4b. b is 5. And now put 5 in for b over there. So 13 is negative a. Sure, that looks like a negative. Plus 15. And subtract 15. Make sure you get a to be positive. Remember, you can't have negative variables. That's Algebra 1 concept. So to wrap this thing up, 3x plus 4, that's like our whole number part. Plus, I've got 2 over x plus 3. Then I've got 5 over x minus 1. And that is your partial fraction decomposition for that one.